Roots. Roots are sometimes called radicals. That comes from the same root as radish. They're fundamentals that build exponents. In this video, we're going to define what the root is for any natural number exponent, and then we'll simplify expressions with roots. A square with length 3 and width 3 has area 9. Length times width is 3 times 3. That's why it's called 3 squared. Now, if we want to go back from the area 9 to the side 3, we take the square root. The square root of 9 is 3 because 3 squared is 9. A cube that has length 3, width 3, and height 3 has volume length times width times height. That's why it's called a cube. 3 cubed is 27. If I want to get back from 27 to the side of a cube, I write the little 3 in the crook of the root sign. And now I have the cube root of 27 is 3. Higher powers don't have the same geometric interpretation as squares and cubes, but 3 to the 4th power, 3 times 3 times 3 times 3 is 81. We can take the 4th root of 81 and get back to 3. Since 5 to the 6th power is 15,625, if I take the 6th root of 15,625, the answer is 5 because it took 6 copies of 5 to make this number 15,625. Now, if I let x be positive, then if I take the nth root of x to the n power, I get back to x. So a square root undoes a square, a cube root undoes a cube, an nth root undoes an x to the n power and gives us back what we originally started with, x. Let's use that to simplify. This expression is the square root of 32x to the 3rd power, and I want to simplify it. So 32 is 2 to the 5th, and x third is 3 copies of x. Since it's a square root, I'm looking for pairs, 2 of the same factor. And there they are. So if I rewrite that, a pair of 2's, 2 times 2 is 2 squared. Here's another 2 squared. And an x squared. And there's a plain factor of 2 and a factor of x that don't have a matching pair. So a square root undoes a square. That 2 comes outside the square root. A square root undoes the second square, and we have another 2 outside. And a square root undoes the square on x squared, and we have x outside. The factors of 2 and x don't have a pair to take them outside, so they have to stay in. So when we simplify this expression, we write it as 4, that's 2 times 2, x, times the square root of 2x. Simplifying a cube root is really similar to this, except we're looking for 3 copies because a cube root undoes a 3rd power. So if I write out the factorization of the expression, I still have 5 2's multiplied and 3 x's multiplied, and I'm looking for groups of 3. So 3 2's and 3 x's are here. That's a 2 to the third and an x to the third. And then there's 2 copies of 2. That's not enough to make 3. So the cube root undoes the cube on the 2, and that gives me a 2 outside. The cube root undoes the cube on the x third. That gives me an x outside. And inside the cube root is left 2 times 2, which is 4. So the simplification of this problem is 2x times the cube root of 4. Here's an expression to simplify the fourth root of 160 times x to the 9th power, y to the 16th power, z to the 6th power. Let's start by factoring 160. 160 is 16 times 10. 16 is 2 to the 4th power, and 10 is 2 times 5. So the factor that has a 4th power here is 2. So I'll rewrite 160 as 2 to the 4th times 10. And I have a 4th power that will cancel with the 4th root. Now to simplify the 4th root of x to the 9, I can write out 9 copies of x and find groups of 4. There are 2. So that is x to the 4th times x to the 4th times 1 left over x. Now, if you think about 9, 4 plus 4 is 8, and x to the 1 makes 9 copies of x. You can see that you could just take away 4 from the 9, that leaves 5. Take away 4 from the 5, that leaves 1. Let's try the 16 like that. If we take away 4 from 16, we have a y to the 4th. There's 12 left. If we take away 4 from 12, we have 8 left. We take away 4 from 8, we have 4 left. And if we take away another 4, we've used up all our y's. 4 plus 4 plus 4 plus 4 makes 16. Well, how about this z? Z is to the 6th power. So if we take away 4 from 6, we're left with 2. Not enough to make another 4. So now we've broken this all down into 4th powers. Let's simplify. 2 to the 4th power lets me take a 2 outside. X to the 4th and x to the 4th, I've got 2 copies of x outside. I've got 4 of the y to the 4ths, so I'm going to have y, 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 and 1 z to the 4th gives me a z outside. Inside is 10 x and z squared. So let's write that out nicely. 2 is multiplied by x squared, that's these 2 x's, and by y 4th, and by z. Inside the 4th root, 10x z squared.